Hi all, welcome to the lecture series on Aerospace Propulsion. Myself, Mr. Manideep Gupta, Assistant Professor, Department of Aeronautical Engineering from MLR Institute of Technology. Today, the topic which we are going to discuss is the calculation of heat of combustion. This is a very important topic which will give us to calculate the energy. Okay, that energy that is going to liberate during the reaction. Okay, this energy is nothing but this energy will be converted to the temperature. It will lead to the rise of temperature in the chamber, and whatever the rise in temperature, that will lead to the expansion of the gases, which will create high pressure in the combustion chamber. So it is a very important in accessing the engine and performance. Okay, this is also very important. This calculation of heat of combustion will help us to find the best suitable propellants according to our requirement. Okay, coming to the overview of today's presentation. In this, first we will discuss what is heat of formation. After that, we will calculate the heat of combustion. Okay, what is heat of formation? Okay, heat of formation is nothing but the enthalpy required. Okay, it is nothing but the enthalpy required. Okay, the enthalpy required to form 1 mole of substance. The enthalpy required to form 1 mole of substance at some condition. What is that condition? At a standard state. At standard state. What is the standard state? That is 25 degrees centigrade and 1 atmosphere pressure. Okay, these are the standard state. So the enthalpy required to form 1 mole of substance at a standard state, that is 25 degrees centigrade and 1 atmosphere pressure, from its basic elements. From its basic elements, which are the elements should be also at a standard state, that is 25 degrees centigrade temperature and 1 atmospheric pressure. Okay, so whatever the enthalpy required to form 1 mole of substance, the enthalpy required to form 1 mole of substance at a standard state from basic elements at a standard state. So this enthalpy required is nothing but called as a heat of formation. Okay, suppose I want to form H2O. Okay, I want to form H2O. How does H2O forms? It is a mixture of hydrogen and oxygen molecules. So what are the basic elements of H2O? Basic elements of H2O are hydrogen and oxygen. If you mix 2 moles of, if you make a reaction between 2 moles of hydrogen plus one molecule, okay, of hot oxygen, then you will get 1 mole of H2O. Half mole of O2 actually it is. Okay, 1 mole of hydrogen with half mole of oxygen will give you H2O. So there the enthalpy has to be calculated by considering the energy required or enthalpy required to form H2O. Enthalpy required or energy required to form H2O molecule from its basic element, that is hydrogen and oxygen, and this hydrogen and oxygen should be at STP condition. This should be at STP condition. This oxygen should be STP condition, and whatever the H2O formed, that should be also at STP condition. Okay, so like this, the enthalpy required to form 1 mole of substance, 1 mole of H2O, 1 mole of H2O at standard state at STP condition from its basic elements, which are hydrogen and oxygen, which are also at STP condition. So this is the definition of heat of formation. Like that, we can calculate heat of formation for any substance. Okay, so this heat of formation is denoted with the symbol delta H naught F. With the symbol delta H naught F. Here delta H, it indicates the enthalpy. Delta H indicates the enthalpy required to form substance from the elements. And next, the subscript F, we can see F here. This subscript F denotes the formation of the substance from its basic elements, and this not denotes that all the elements are formed at a standard state. Okay, the subscript O denotes the both elements and substance formed from the elements which are at standard state. So delta H means enthalpy required. Okay, and not symbol denotes that elements are at standard state, and F is the elements, the substance is formed from basic element. Okay, so this is the symbol description, delta H naught F, which is called as heat of formation. Suppose if I want to represent the heat of formation of H2O, then how should I written delta H naught F of H2O? That means heat of formation of H2O. Okay. Example, chemical reaction of element. Here we can go through one example. The chemical reaction of element carbon in solid phase with gaseous oxygen to form carbon dioxide. So, carbon plus oxygen will give you CO2. So, according to the heat of formation definition, the carbon dioxide should form from basic elements. So, carbon is a basic element, oxygen is a basic element, and carbon at STP condition at standard temperature will be in the solid form, and oxygen at the standard condition will be in gaseous form. Okay, carbon in solid form and oxygen in the gaseous form react and forms CO2. This CO2 also should be at STP condition. At STP condition, the CO2 will be in the gas form. The phase of the CO2 is gas. So, then whatever the enthalpy required to form CO2 like this, that is nothing but called heat of formation of CO2, right? So, if we measure the heat of formation of CO2 like this, the value we'll get is 32,800 kilojoules per 1 kg of carbon burn. 32,800 kilojoules per 1 kg of carbon burn. If you burn 1 kg of carbon with the sufficient oxygen, with the complete carbon burn, then you will get 1 mole of CO2 here. Okay. The energy released is 32,800 kilojoules. So, this is nothing but the heat of formation of CO2. So, if you consider the formation of water, next example for formation of water. Okay, generally water will be in the liquid state at STP condition. So, H2O liquid. From its elements, what are the basic elements? Hydrogen and oxygen, right? Hydrogen and oxygen at standard state 25 degrees centigrade and 1 atmosphere. So, the equation will be, we have already discussed this, right? H2 plus half O2 gives rise to H2O. H2 at STP condition, which is in the gas form, and oxygen at STP condition in the gas form, and H2O at STP condition in the liquid state. Okay. So, the heat generated during this reaction is 286 kilojoules per mole. Okay, 286 kilojoules per mole of water form. So, to form 1 mole of H2O, this much energy is, this is the heat generated during this form of 1 mole of H2O. That is nothing but heat of formation of H2O. So, in order to maintain the isothermal conditions, 25 degrees centigrade, okay, this 286 kilojoules heat needs to be taken out from the system. What happens here is, the heat generated here, the heat generated is 286 kilojoules, right? So, 286 kilojoules of energy is released. Okay, this is energy is heat generated during this reaction. So, whatever the water molecules forms, that will absorb this energy will be transferred to the H2O, right? This 286 kilojoules energy will be transferred to the H2O. Okay, then what happens to the H2O molecule? The temperature of H2O molecule will increase. The temperature of H2O, whatever the energy transferred to the H2O, this energy transferred to the H2O, right? This temperature will increase. So, but what is our condition according to heat of formation? The H2O should be at STP condition. What is the STP condition? 25 degree centigrade and 1 atmosphere. So, here whatever this 286 kilojoules increases the temperature. So, in order to stop increasing the temperature of H2O, what we have to do? We have to remove that 286 kilojoules of energy from the H2O. Then H2O will be at STP condition. So, that is what explaining here. In order to maintain the isothermal condition, that is 25 degrees centigrade, 286 kilojoules needs to be taken out from the system. So, the heat of formation of H2O is nothing but minus 286 kilojoules per mole. This amount of energy has to be removed. So minus 286 kilojoules per mole is the heat of formation of H2O. So the heat of formation of the elements. So here there are some heat of basic elements. The heat of formation of elements like hydrogen, nitrogen and oxygen at 25 degrees centigrade and 1 atmosphere pressure and by these are 0. By default, we can consider the heat of formation of hydrogen, nitrogen and oxygen, okay, and carbon are equal to 0. So for the liquids and solids, the reference state is the real state and the substance real state of the substance at 25 degrees centigrade, right? Suppose if you take hydrogen or reference state, elemental reference state means that state either it is gaseous or liquid or solid at 25 degrees centigrade. That is nothing but the reference state, okay. So reference state has to be taken at 25 degrees centigrade. And the heat of formation of different substance in solid, liquid and gaseous phase can be determined by knowing the heat generated or absorbed during the formation of elements in the standard state. Okay, we can easily calculate the heat of formation of any substance by knowing the elements like heat of formation of the basic elements. Okay, so here H2 plus half O2 is giving the H2O, right? So here we have to calculate the heat of formation of H2O. How do you find the heat of formation of H2O? If you know the heat of formation of hydrogen and if you know the heat of formation of O2, then easily we can calculate the heat of formation of H2O. So next, heat of combustion. Next, heat of combustion. So how do we get the heat of combustion? Right? What is heat of combustion? Heat of combustion refers to the energy liberated in a chemical reaction. The heat of combustion is nothing but the energy liberated during the chemical reaction. So this heat of combustion is different, heat of formation is different. Heat of formation is the energy required to make a substance at STP condition. But heat of combustion is not like that. Heat of combustion is the energy required to form a particular substance from the stable elements when both are at a standard state. So at a standard condition of 1 atmosphere pressure and 25 degrees centigrade, the heat of combustion, whatever the heat of combustion, it corresponds to the negative of the difference between the heat of formation of products and heat of formation of the reactants. So when both reactants and products are at a standard state. Okay. So heat of, suppose A plus B equal to C. The heat of combustion is nothing but heat of formation of products delta H naught F of C minus of B plus A. Okay. So it is nothing but negative of the difference between the heat of formation of the products, these are the heat of formation of product, and the heat of formation of the reactants, heat of formation of reactants. So whatever the excess energy in the reactant above the product is available as heat and goes to increase the temperature of combustion product. Suppose if you take reaction A plus B is equal to C, okay, the product, suppose heat of formation of A is some 10 kilojoules per mole, okay, and this is 10 kilojoules per mole, and the heat of formation of C is only 5 kilojoules or suppose it is 5 kilojoules per mole. So what is the difference? It is 5 kilojoules and it is 10 plus 10, 20. So there is a 20 minus 5. There is a difference of 15 kilojoules of energy per mole. So whatever this 50 kilojoules of mole difference, the energy that will be liberated during the reaction. Okay, suppose instead of 5 kg, if it is 25 kilojoules per mole, okay, heat of formation is 25 kilojoules, then what happens? Here it is only 20, here the energy is 25, that means you have to give some extra energy, 5 kilojoules extra energy to form the element, the product, C here. Okay. So this is how we can calculate, we can estimate the energy, either the energy liberates during the reaction or energy has to be supplied to perform the reaction. That can be easily calculated with the help of this equation, that is heat of combustion. So it is nothing but minus of, negative of sum of the heat of formation of the products and sum of the heat of formation of reactants. So example, if we consider the heat of formation of water, the same heat of formation of water at 25 degrees centigrade, so from its basic element hydrogen and water at 25 degrees centigrade and 1 atmosphere. So the standard heat of formation of H2O is how much? Minus 286 kilojoules per mole heat of formation. And next H2 and O2 being standard elements, and these have heat of formation 0. We have already discussed. The heat of formation of H2 is 0 and oxygen is also 0. So if I want to calculate heat of combustion for this reaction, then what happens? The heat of combustion for this reaction will be, the reaction is H2 plus half O2 equal to H2O, and the heat of formation of product, what is product here? H2O liquid. So heat of formation of product H2O minus of sum of heat of formation of H2 and heat of formation of O2. So from the here the heat of formation of H2 is how much? Minus 286, minus of minus 286 minus sum of heat of formation of H2, that is 0, heat of formation of oxygen is also 0. So 286, it is a heat of combustion. So finally 286 kilojoules per mole. So this is the heat of combustion for water. So how much energy is going to generate? 286 kilojoules per mole of energy is being generated when you react hydrogen with oxygen. So the negative sign shows that energy must be removed from this reaction in order to make H2O to be at a standard state. Okay. So as we know, the 286 kilojoules per mole is generating, so this reaction is called exothermic reaction. And the heat goes to increases the temperature of H2O, discuss, right? So this is about the heat of combustion and heat of formation. Heat of combustion has a formula. The heat of combustion formula is a negative of sum of the heat of formations, difference between the heat of formations of products and heat of formations of the reactants with negative sign. Heat of formation is different. Heat of formation is the energy or the enthalpy required to form 1 mole of substance at a standard STP condition from its basic elements, which are also at STP conditions. So this is about heat of formation and heat of combustion. So this is the summary. We have gone through the heat of formation, definition of heat of formation with one example, formation of H2O, and also we have calculated the heat of combustion with the help of 2 examples. One is carbon reacted with oxygen and hydrogen reaction with oxygen. So this is about the heat of formation and heat of calculation of heat of combustion. Thank you.